In 1996, Gosford City Council commissioned a geotechnical study of the Tudibaring Headland area at Copacabana, which is north of McMaster's Beach. The study was needed because of the large caverns and open joints and general appearance of instability observed during a general coastal study of the Central Coast in 1995. These large caverns occur near the base of the cliff area and have been formed by weathering and wave erosion of the rock units at Tudibaring Headland. Generally, along the base of the cliff area is a soft siltstone claystone material, which is the prime cause of much of the instability. It is these variations in rock strength and type, combined with a prominent north-south rock jointing system, that gives rise to the instability in much of the headland area. In some locations, recent rockfalls have occurred. Whilst the size of the northern cavern is less than the southern cavern, active sea erosion in this cavern is having a major influence on the stability of the entire cliff area. The caverns have a significant effect on the stability of the land behind the cliff. This effect has been classified into 4 hazard categories, with hazard category 4 being the immediate high hazard and the lowest category 1 being effectively stable. These hazard categories are necessary because the effect of cliffline recession extends well back into the cliff area as the joints in the rock mass open up in the area behind the cliff. As a consequence, some properties near the top of the cliff are affected by future weathering and undercutting of the cliff area. Whilst the continuing wave action against the base of the cliff is the prime cause of the cliff weathering and recession of the Tudibaring Headland, there are many other causes. These include differential rock weathering, seepage, and massive joint block instability. As this weathering process continues, extensive undercuts develop under the massive sandstone units, but many of these undercuts are caused not by wave action, but by the differential rock weathering process. When an undercut gets large enough, a major area of the cliff fails in a large rockfall. The northern cavern is the smaller of the 2 large caverns at Tudibaring Headland. This cavern is extending at a substantial rate because of the soft siltstone forming the sides of the cavern and the prominent open joints at the back of the cavern. These open joints seem to extend many metres into the cliff face. The council reserve forming the cliff-top area occupies a wide space between the existing housing development and the headland area. Generally, the space is very large, but in places the distance is less than 6 metres. The cliff area to the south and southeast of the houses has prominent open joints and is extensively weathered in the upper section. The cliff area was investigated by abseiling techniques utilising specialised personnel. During the 4 cliff descents, detailed cross-sections were drawn and careful observations were made of the various weathering features, rock joints and type. Each descent took about 3 to 4 hours to complete. The weathering pattern observed is related to the difference in rock strength and hardness, as well as the prominent joint pattern. In the upper area of the cliff line, a soft claystone material is exposed over a considerable portion of the study area. This claystone material weathers much more rapidly than the remainder of the headland rock units. In the cliff supporting pillar between the northern and southern caverns, significant rock stress cracking was observed. These stress cracks increase the rate of enlargement of the cavern and will ultimately lead to the development of one very large cavern, with resultant major effect on the cliff stability. Towards the south of the study area, near lot number 876 Del Monte Place, the headland exhibits considerable open joints and has extensive stress cracking within the large overhanging section of the headland. A striking feature of the whole headland area is the massive joint system and the extensive weathering and differential weathering of the various rock units. Observation of the differences in colour of the exposed rock units also suggests that large-scale rock falls are a regular occurrence. The caverns themselves are very large, and it would be easy to fit a 6-storey building in the southern cavern. As discussed earlier, the southern cavern was mainly formed by differential weathering and the action of the sea. Now, however, the stresses induced into the cliff rock are initiating a secondary process causing crumbling and fracturing of both the sides and roof of the cavern. In the cavern itself, there is evidence of continuing rock falls, many of which are induced by the high rock stresses in the roof area of the cavern. The debris in the base of the cavern is the result of these rock falls from the roof and stress cracking from the side walls. When standing in the cavern, one gains a sense of awe at the sheer size of the cavern and the obvious high stresses in the rock. The weathering processes are also aggravated by seepage and water flow over the clifftop area. Near the northern end of the study, near lots number 888 to 892, there is a major undercut cliff area which extends for about 50 metres and has a depth of undercut from about 4 metres to 16 metres. Over the top of this is a substantial sandstone cliff. Underlying this undercut area are variable softer rock strata which weather at a rapid rate due to the action of waves and storms. Above the undercut area, notice the steep near vertical joint system and the seepage over the rock area. In some of the more weathered areas of the cliff, there are extensive open joints and individual blocks of rock can become dislodged as a result of weathering and joint patterns. These blocks of rock can fall to the platform below without any warning. As such, they're a hazard to any persons on the platform below. Some blocks of rock seem to remain on the cliff face without any visible means of support. The overall recession pattern of the headland is one of differential weathering of the softer and harder seams of rock, which give rise to extensive rock overhangs. Not all the weathering is just soft and hard rock weathering. Some of the weathering is related to the structure of a particular rock unit itself and gives rise to fascinating weathering patterns. These ones are called honeycomb weathering. Seepage is also a major factor in the weathering process. Seepage over the cliff area also aggravates the whole instability process. Towards the northern end of the study area, on the southeastern side of lots number 891 to 896, there is a right-of-way for access and drainage purposes. This right-of-way was constructed at the time of the subdivision and is presently extensively eroded. The right-of-way now forms a concentrated water path for runoff from the north towards the council reserve area near lots number 884 to 888. It would also appear that much of the concentrated runoff is the result of the driveway area near lot number 896. The concentrated runoff down the right-of-way towards the central unstable cliff area is increasing the extensive natural seepage over the cliff and thus possibly increasing the rate of cliff line recession in this area. The geotechnical study has resulted in the development of a hazard map for the area, which has been compiled by a consideration of the way in which the cliff line will probably recede. The map delineates the hazard into 4 categories, ranging from Category 4, immediate high hazard, to Category 1, low hazard. This hazard rating is similar to the widely adopted hazard classification for coastal beach studies. Because of the potential for instability in Category 3 and 4, new development in the clifftop area should be restricted to the Category 1 or 2 areas. It will, however, be important to take some special precautions in the design of buildings within Category 2, because of the possibility that within the design life of the house, there will be some small opening of joints in the bedrock under the house building area. Building works are continuing in Del Monte Place, and whilst many of the existing buildings are quite appropriate for the area, some are not. In the Category 2 area, buildings need to be flexible. Brick buildings with adequate flexibility and timber panels, such as the one shown here, are quite suitable for the area. Sometimes, however, builders do not follow the designer's instructions and fail to continue joints right through the brickwork. Thus, a joint of this type is quite useless. Also, many buildings near the centre of the study area, where the risk is greater, do not have any flexibility at all. As a consequence, it may be prudent to alter these houses so that they incorporate a degree of flexibility in the future. The study has shown that if sensible precautions are taken and appropriate limits established on development, the houses in Del Monte Place should be safe from recession of the Tudibaring Headland for their design life.